Okay, so today we're going to talk about some of the homework problems on 6.6. So we're going to do, let's start with number 45. We'll do 45 first. 45 says, find the fifth roots of the complex number. So 45, find the fifth roots of the complex number. The complex number is cosine pi I sine pi. So obviously we don't have to convert it to polar form because it's already there. So we just have to take the fifth roots of this. So the fifth roots would be CIS, since there's a 1 here, and we don't have to worry about the absolute value because the value is 1 here, the magnitude is 1. So we're going to have pi plus or minus 2k pi over 5, where k is going to be equal to 0, 1, 2, 3, and 4. Okay, from 0 and 5 of them, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, so the first one was k is equal to 0, so k is equal to 0, so we get CIS pi over 5. The second one would be CIS when k is equal to 1. So we would have 3 pi over 5. And then when it's 2, we get 5 to get 4 pi here. Pi plus 4 pi is 5 pi. Divided by 5 is pi. So that would be CIS pi. And then we would have CIS when it's 3. 3 times 2 is 6. Plus 1 is 7, so it would be 7 pi over 5. And the last one is when k is equal to 4, so that would be 8 pi here, plus 1 would be 9 pi. So we're going to CIS 9 pi over 5. Okay, and so that would be your answer. It doesn't tell us to put in the answer in any specific form, so this form here would be just fine. Okay, so that would be 45. 51. Find the nth roots of the complex number for the specified value of n. Okay, so in 51, we're going to have, the number is 1 plus I. Okay, so this obviously is not in polar form. So we need to go ahead and convert this into polar form first. So if you take the magnitude of this, you're going to get the modulus, right? The modulus would be 1 squared plus 1 squared here, the square root of that, so it would be square root of 2. So it's going to be equal to the square root of 2. And to get the 1, we would have 1 over square root of 2, I 1 over root 2. Okay, so we have to find the angle where the cosine value is 1 over root 2 and the sine value is 1 over root 2. So that would be what? That would be pi over 4. So we would have, this is going to be root CIS pi over 4. Okay? And we are asked to do what? We are trying to find the fourth roots of these. So since the fourth root, so we're going to go ahead, I'm going to go ahead and put this in this form. Okay? So I have to take the fourth root of that. So I'm going to take the fourth root of that, so we're going to get what? 2 to the 1/8, right? Because we had 1/4 here. I'm going to take a quarter root of that, right? And then I'm going to have CIS pi over 4 plus 2k pi over 4, because it's the fourth roots, okay? So k is going to be equal to 0, 1, 2, and 3. 4 of them, right? 0, 1, 2, 3. So when k is equal to 0, I'm going to get this is equal to 0, so I'm going to get what? 2, 1 over 8, CIS, 1/16 pi. Second one would be 2, 1 over root, CIS. Now k is equal to 1. When k is equal to 1, what do I get? I get 2 pi here, so I get quarter plus 2 pi, right? Quarter plus 2 pi. So I'm going to get 2 1/4, which is the same as 9 over that. We divide that by 4, so it's going to be pi over 9 pi. Okay. Then when when k is equal to 2, I'm going to get what? 4 here. 4. So it's going to be 4 and a quarter. So it's going to be what? 16, 17. So I'm going to get 2, 1 over root A, CIS, and divide that by 4. So it's going to be 17 over 16. Right? The last one is going to be what? Last one is going to be 3. What is going to 3? So we're going to get 6 pi and quarter. So it's going to be 6 and a quarter. So it's going to be 24, 25. So I'm going to get 2, 1 over and 1/8. CIS 25 pi over 16. Okay? So that's 51. So we move on to 57. On 57. Let's see what we're asking for. On 57, we're going to have the cube roots of unity. Cube roots of unity. So unity is what? 1, right? 1. So we need to put this in polar form. This is not in polar form, right? Because this is basically 1 plus 0i right here, right? So we're going to have to put this in polar form. In polar form, this is what? So I have to find the angle where the cosine is 1, the sine is 0. So what is that? That is basically cosine 0 plus I sine 0. In other words, it's CIS 0, right? CIS 0. And we are asking for the cube roots. So it's going to be what? CIS 0 plus 2k pi over 3, right? So it's 3 roots. So k is going to be equal to 0, 1, and 2, right? When k is equal to 0, I get 0, 0, so I'm going to get what? CIS 0, right? And then when I am k is equal to 1, I get 2 pi, so it's going to be 2 pi over 3. And then last but not least, I get CIS when k is equal to 2, I get 2 pi, so that's going to be 4 pi over 3. And it says express the roots in the standard form, which means a plus bi. So I have to transfer these into standard form. So it's going to be cosine 0, I sine 0. So this is 1, this is 0, so this is 1, right? 1 makes sense, right? The cube root of 1 is 1. Well, it has to be 1, right? And then I'm going to get cosine 2 pi over 3 plus I sine 2 pi over 3. So cosine 2 pi over 3 is what? Cosine 2 pi over 3 up here. So we're looking at -1/2 plus sine of this is going to be what? Sine, wait a minute. Yeah, sine is going to be root 3 over 2i. Okay, and the last one is cosine 4 pi over 3 plus I sine 4 pi over 3. 4 pi over 3 is where? It's down here, right here. So you get what? Cosine is still going to be -1/2 plus root 2i, except this guy here is going to be negative now because we're down here in the third quadrant where the cosine and the sine are both negative. Okay, so that was 57. So 57. Yeah, we're good with that. Okay, so that was 57. Now let's do 61. So we're through to here, and we're going to do 61 now. 61 and 62 are a two-step problem. They're actually going to give you one of the roots, and you have to find the rest. Okay? So in 61, we have what? 61, we're going to get determine z And the 3 cube roots of z, if one of the cube root of z is 1 plus root 3i. So this is one of the solutions. They're giving you one of the solutions, okay? So we're going to work this backwards. So first of all, let's go ahead and define what this is. So the argument here, or the modulus is going to be this squared plus this squared, 1 plus 3, and the square root of that. So that's square root of 4, so it's going to be 2. So 2, which means this would be 1 half 2i as such. Okay, so now I have to find the angle, which the cosine value is this, and the sine value is this. So this is obviously in the first quadrant, because they're both positive. So cosine is 1 half, and sine is that, so it's going to be pi over 3, right? 2 cis pi over 3. So this is one of your solutions, which means that when I cube this, I will get the original question that I started with, the original number, right? So we were trying to find the cube roots of this, right? Because if I take this root and I cube it, I should get the original question. So it's going to be 2 cubed cis pi over 3 times 3 is going to be pi. So this is 8. So it's going to be 8 cosine pi plus I sine pi. Sine pi goes to 0. This is negative 1, so it's going to be negative 8. So negative 8 was the original number that I was trying to find the cube roots of. Okay, so now I have to go back and find the cube roots of these. I'll find 3 of them, and one of them should be this. Okay, all right, so let's see if we can do that. So I have negative 8 cis 0, right? Because it's 1, right? Because this has to be, since I have the negative 8 out here now, this has to be 1, so it's cis 0, right? It's because this is what? Negative 8 cosine 0 plus I sine 0. Again, this goes to 0. This is 1, so all I have left is negative 8. So this is the correct expression. So now I'm going to take the cube, I'm going to find the cube root of this. So what do I get? I get negative 8, 1 cubed, cis 0 plus 2k pi over 3, where k is equal to 0, 1, and 2. Okay, so those are my 3. So let's go ahead and find those. So the first one, the cube root of negative 8 is negative 2. Negative 2 cis, when k is equal to 0, I'm going to get 0. 2 cis, when k is equal to 1, I'm going to get 2 pi over 3. And then negative 2 cis, when k is equal to 2, I get 4 pi divided by 3. So these are my 3 roots. This guy here was what? Negative 2. Okay. This guy here is what? This guy here is negative 2 cosine 2 pi over 3 plus I sine 2 pi over 3, which is what? This is negative 2 times, what is this? Cosine 2 pi over 3 was over here. So cosine 2 pi over 2 pi, or cosine the value is negative 1 half. So I'm going to get negative 1 half, and then plus sine 2 pi over 3, which is root 3 over 2i. Okay? Then over here, I'm going to get negative 2 cosine 4 pi over 3 I sine 4 pi over 3. Okay? So that's going to be down here. Negative 2. Cosine value is negative 1 half. Negative 1 3i. So if I do this out, what do I get? I get here, I get 1 minus root 3i. And over here is 1 plus root 3i. So this we got. So this is actually a good way to verify that we actually did the question correctly, because they've given us this one root. And the question was, what were the other two roots? So the other two roots would be this guy and this guy. So that would be your answer. Okay? Again, two-step process. So you have to cube the one root that they gave you to find the original question, and then find the rest. Okay? Let's see if we can do the same thing with 62. On 62, we have determine the fourth root if one of the fourth roots is -2 and -2i. So I have -2, -2i. Okay. So what do I get here? I'm going to get what? I'm going to get 2 squared plus that squared, right? So it's negative. So it's root 8. So I'm going to get root 8, which is like that, which is what? This is 2 root 2, correct? 2 root 2. So in order to get that, I need to have what? 1. So I'm going to multiply these two, I'm going to get -2, right? The same thing over here. Like that. Right? So where I have to find I have to find the argument or the angle here, right? So it's going to be down here, which is what? 2 root 2 CIS 5 pi over 4, right? 5 pi over 4. Okay? And I'm trying to find this is one of the fourth roots. So I have to take this. Now I have to take the fourth of this, right? To the fourth, right? So this was root 8, right? So the fourth would be 64. So I'm going to get 64, and I'm going to get what? CIS 5 pi. Okay? 5 pi is what? 5 pi is the same as pi, correct? Because I can subtract 4 pi and it would still be the same, right? Because I can go around 1, 2 pi, and another 2 pi would be 4 pi, right? Okay, so this is the original question. So this was the original question they were asking for. And what am I trying to find? So determine z. So the z would have been what? So this would have been z, right? This is z, which is what? This is 64 cosine pi plus I sine pi. This goes to 0. This is -1, -64. So this is z. So that's the first question. Now I have to find the other roots. So I'm going to take this guy and take the fourth root of this right now. So I'm going to go ahead and take the fourth root of these. So I'm going to have to take the fourth root of these, right? So what do I go back? I get back to 2 root 2 CIS pi plus 2k pi over 4, where k is equal to 0, 1, 2, and 3. Okay? Right. So when I get 0, what do I get? I get 0, I get 2 root CIS. This is 0, so I get pi over 4. And then I get 2 root 2 CIS when k is equal to 1. I get 3 pi over 4. Equal to 2, I get, this is 4 pi, so this would be 2 root 2 CIS 5 pi over 4, 2 root 2 of 3, when it's 3 I get 6 pi, and that's 7 pi, CIS 7 pi over 4, okay? So, what is this? This is 2 root 2. So let's go ahead and put these in now into regular or standard form. They want us to put in standard form, so let's go ahead and do that. 2 root 2 CIS pi over 4 is 2 root 2 cosine pi over 4 plus I sine pi over 4. So this is 2 root 2 cosine, that is 1 over root 2 plus I 1 over root 2. So I get 2 plus 2i. Was this the original one? What was the original, the one that they gave us? And there was a negative, okay. So that's 1. Second one, so that was that one. So let's do this one here. 2 root 2 CIS 3 pi over 4. 2 root 2 cosine 3 pi over 4 plus I sine 3 pi over 4. So what I get here, I get 2 root 2. This guy is, well, now we're over here. So it's going to be negative 1 root 2 plus 1 over root 2i. So I get negative 2 plus 2i. So those are those two. So the third one was 5 pi over 4. 4 is equal to 2 root 2 cosine 5 pi over 4 plus I sine 5 pi over 4. So this, now we're down here. So it's going to be 2 root 2 negative 1 over root 2 negative 1 over root 2i. So if I multiply this, I get negative 2 negative 2i. The last one is 7 pi over 4. So I get 2 root 2 cosine 7 pi over 4, I sine 7 pi over 4. So that's down over here now. So what do I get? I'm going to get 2 root 2 cosine is this. Negative 1 over root, because sine 7 pi over 4 is negative. So if I do this, I get 2 minus 2i. So these are my 4, 1, 2, 3, 4 are my roots, and I can verify again, since one of them was given to us as negative 2, negative 2. So it's negative 2, negative 2. This is the one that was given to us. So the other three would be this guy, and that. Okay, again, so you had to take the one root, put it in the polar form, and then take the fourth of that to get the original z, which was negative 64, and then we went ahead and did this all the way